Hey, Janardhan, Vivek,
Sir?
am I audible to all of
Yes,
you?
sir. Yes, sir.
Yes, sir.
Hope my screen is visible.
Yes, sir.
Yes, sir.
As for the other friends,
Okay, sir.
yeah. So let us start the session. So it's on transportation. So in our previous class, we were discussing about transportation engineering. So in that, we covered geometric design of highways and the cross-sectional elements of the same. And we discussed about side distances, different side distances like stopping side distance, overtaking side distance, intermediate side distance, headlight side distance. All these things we discussed, and we discussed about horizontal and vertical alignments like super elevation, extra widening of road, and then vertical alignment and different cases under the same. So in today's session, we'll discuss about a geometric design of railway track, speed, and highway pavements, desirable properties of highways, and materials and desirable properties of bituminous pave mixes, etc. We are going to discuss, and then a design of flexible and rigid pavement using IFC code. These things we are going to discuss in today's session. So let us start with geometric design of railway track. So what is the necessity of geometric design of a railway track? So necessity is we should have, it should possess a smooth and safe running of trains on it, and it should be able to attain the maximum speed on the tracks, and it should be able to carry heavy axial load on it, and as much as possible it should avoid accidents and derailments, and less maintenance efforts is required once it is constructed, and also it should possess a good aesthetic value. So these are all some necessities of a geometric design. So most of things were the same in highway geometric design also. Few things are different, and there, if all the above elements are properly designed, the possibility of derailments due to defects in track can be avoided. So these are all some necessities and objectives of geometric design of railway tracks. And in this, it is important to discuss about the gradients. You know what do you mean by gradients? The amount of a slope in longitudinal direction of a railway track. It is called as a gradient, or it can also be called as grade. So gradients are provided to negotiate the rise or fall in the level of a railway track. So that is the necessity why we are going to provide the gradients. So rising gradient raises the track in the direction of movement, whereas falling gradient causes the track to go down in the direction of movement. So two types of gradient, rising gradient and falling gradient. So a gradient is represented by distance traveled for a rise or fall of one unit. So that is why we express it as written as 1 in x. So this 1, it is in vertical direction, rise or fall, and x, it is in longitudinal direction, which is traveled. Or you can also represent 1 in n, whatever the variable you want, you can use. Yeah. So you can see rising gradient over here. So gradient with the 10%, quite a steeper gradient, and then grading with little flatter, that is 4. So gradients are provided on track due to some of the following reasons. So gradients are provided to provide a uniform rate of rise or fall as far as possible, and to reach the various stations located at different elevations. If you take the length of a railway track, the elevation throughout its length cannot be same because the topography of land throughout its length and wide area, it is different. And if you try to maintain the same level throughout the length of railway track, it will become an uneconomical project. So due to these reasons, it is important to provide gradients throughout wherever it is required, and it is to reduce the cost of and the different types of gradients: rolling gradient, momentum gradient, pusher gradient. You can also call it as a helper gradient. Gradients in station yards. So four types of gradients are there. First one, ruling gradient. This is the design gradient basically. So this is the gradient we are going to take for the design in majority of the time, because it is determined on the basis of performance of locomotive, and at the same time it tries to look at the total amount of load which that locomotive can take along with it. So while negotiating any gradient without the loss or major loss in the speed, the moment. So the load which is taken on locomotive, it is considered and analyzed. And it is a maximum gradient, steepest gradient that can be provided, which may be permitted on the section of track, and it is determined by the maximum load that a locomotive can haul with maximum permissible speed. So without negotiating with the permissible speed, how much load a locomotive can take. Based on that, this ruling gradient will be determined. Extra pull required by locomotive on a gradient with inclination. So that can be calculated by P equal to W sine theta. So sine theta is nothing but gradient. You can refer this sketch for this equation which is derived. So extra hull which is required. If you resolve this weight of this train along this inclination, you will get this W sine theta. So for example, if the weight of the train, if it is 500 tons, and the gradient which is provided, it is 1 in 100. So in such cases, the extra force which is required to pull the locomotive, it will be 1 in 100 of 500 tons. You calculate it, you are going to get 5 tons. So in the same manner, another example, if the weight of a train, it is 500 tons, and the gradient which is provided 1 in 200, the extra force required to pull the locomotive, it will be 1 divided by 200 of 500, it will be 2.5 tons. So this is how to calculate the extra force which is required to pull the locomotive. And the ruling gradient with one locomotive, if it is in a plain area, so the ruling gradient can be provided in the range of 1 in 150 to 1 in 200. If in case of hilly area, you can go for still more steeper ruling gradient, that is 1 in 100 to 1 in 150. In that range, you can provide ruling gradient. So once a ruling gradient is specified for a section, so then all other gradients provided in that section should be flatter than the ruling gradient. And after making the due compensation for curvature, this gradient is finalized. And the next type of gradient, it is a momentum gradient. Momentum gradient, it is steeper than ruling gradient. So that is overcome by momentum which is gathered while moving, while having a run in the plane or on falling gradient. So here a falling gradient, a rising gradient which is followed by a falling gradient. In such cases, a locomotive is going to attain certain kinetic energy. Use of additional kinetic energy which is received during the run on a section, here we are going to do. And no obstruction like signals are provided on the section with these gradients. So such things are not acceptable when momentum gradient is provided. Means train should not be stopped at the territory of momentum gradient. It is not acceptable. So you can see the diagrammatic representation of a photo where momentum gradient is provided. It's a falling gradient and this is a rising gradient. So here to climb this steeper gradient, it is using the kinetic energy which is stored while locomotive is passing through. So for example, in valleys, a falling gradient is usually followed by rising gradient acquires sufficient momentum. This momentum gives additional kinetic energy to the moving train, which would enable the train to overcome a steeper rising gradient than the ruling gradient for a certain length of track, so that you can go for providing momentum gradient there. So this rising gradient is called as momentum gradient, and this gradient is steeper than ruling gradient. So you can see a bicycle rider, so who will attain kinetic energy while passing through this falling gradient. So it is utilized while climbing this rising gradient. And the next type of gradient, it is pusher or helper gradient. So this gradient is steeper than a ruling gradient, requiring extra locomotive to pass through that. It will reduce the length of a railway section, and it also reduces overall cost. So only in such cases pusher or helper gradient are going to be provided. So huge amount of earthwork need to be done, and if it is uneconomical to flatten the uh, terrain over there, so in such cases pusher gradient or helper gradient can be provided. So for example, in places like Darjeeling or there, 1 in 37 pusher gradient is used. And if you come to Western Ghats section with the broad gauge tracks and narrow gauge tracks, 1 in 25 is provided. So certain standing examples for pusher or helper gradient. So a helper gradient of 1 in 75, 1 in 100 with the additional 1 inch is used. So you can see this for pusher gradient. And fourth type of gradient, it is gradient at station yards. So as far as possible, the track along the stations and yards should be level, or gradient should be sufficiently low as much as possible. So here the objective is to prevent the standing of vehicle from rolling and moving away from the yard due to combined effect of gravity as well as strong winds. There may be some chances. And then to reduce the additional resistive force required to start a locomotive to the extent possible. And then third point, the minimum gradient from the drainage considerations, it will be given at station yards. So on Indian railways, maximum gradient permitted is 1 in 400 in case of station yards, and minimum gradient which is permitted, it is 1 in 1000 in view of drainage consideration. So you can see the platform gradient or station yards gradient at over there. You can see over here. And now it is a grade compensation on curves. If a curve is provided on a track with the ruling gradient, the resistance of the track will be increased on this curve. So in order to avoid resistance beyond the allowable limits, the gradients are reduced on curves, and this reduction in gradient is called as grade compensation. So same concept we studied in highway geometric design also. Over there also on horizontal curves, if gradient was there, so compensation of grade we are doing. So in India, compensation for curvature, it is in case of a broad gauge 0.04% per degree of curve. If it is a meter gauge, 0.03%, narrow gauge, 0.02% per degree of curve. So one example, if the ruling gradient is 1 in 250 on a particular section of a broad gauge, and at the same time a curve of a 4 degree is situated on this ruling gradient, what should be the allowable ruling gradient? So as per Indian railway recommendation, the grade compensation for broad gauge track, just now you saw it is 0.04% per degree of curve. So therefore 0.04% and degree of curve it is given over here, it is 4 degree. So 0.0 of 0.4 of 4, it is 0.16%. So the ruling gradient over here, it is 1 in 250, it is given here. So 1 in 250, it is 0.4%, the ruling gradient is provided. So therefore, required ruling gradient or actual gradient, it will be equal to ruling gradient minus grade compensation. So how much we are reducing the ruling gradient? So it is 0.4 minus 0.16. So 1 in 250 means 0.4%, and grade compensation we are going over here, it is 0.16, so that it is 0.24%. So that is 1 in 417. And then radius and degree of curve. The main curved portion of a railway track is kept circular. That is the radius at every point of curve, it is same. So the radius of a railway curve is sometimes represented by degree of curve. So here the degree of curve, relationship between radius and degree of curve, you can see here. If you are using a 30-meter chine, so in such case, the degree of curve, it is calculated by 1720 divided by R. Okay, and this degree of curve, it will change if the length of chine is different. In case here, if we have used 30-meter chine, if it is a 20-meter chine means this equation is going to be changed. And the degree of a railway curve, the angles obtained at the center of curve by an arc of 30 meter, as we have used 30-meter chine over here, that is defined as degree of curve. And the safe speed on curves. Safe speed for all practical purposes means a speed which is safe from the danger of overturning, from the danger of derailment with a certain margin of safety. This speed to negotiate curves safely, okay, that speed is called as safe speed, and this speed depends upon few factors, that is a gauge of the track and radius of curvature and amount of the super elevation which is provided. And the calculation of this safe speed, you can use these formulas for broad gauge and meter gauge. You can use V equal to 4.35 into root of R minus 57. It depends on radius. And if it is a narrow gauge, then it is 3.65 into root of R minus 6. So these two equations you can use for the calculation of safe speed. Next, super elevation or cant. So when a train moves around a curve, it is subjected to a centrifugal force acting horizontally at the center of gravity of each vehicle, radially away from the center of the curve. So this centrifugal force is making the vehicle to topple, rail to topple. So this increases the weight and also it will increase the weight on outer rail. So to counteract this effect of centrifugal forces, the level of the outer rail is raised above with respect to inner rail by certain amount. So this will introduce a certain centrifugal force. This raised elevation of outer rail above the inner rail at the horizontal curve, it is called as cant. So diagrammatic representation of the cant you can see here, and mathematically it is the difference in elevation between the outer rail and inner rail at a horizontal curve. So that is the third cant. Inner rail is taken as a reference rail and is maintained at its original level, and inner rail is also known as gradient rail, and it is denoted by cant is denoted by E. So some of the objective of providing super elevation, it is for neutralizing the effect of a centrifugal force, and equal distribution of wheel load will happen. So here to provide the smooth track and improving the passenger comfort, and it is to reduce wear and tear of the rails and rolling stock. So these are all some objectives of providing super elevation. So you can see over here. So there is a horizontal curve along the length of a railway track, and the outer edge of rail is raised with respect to inner rail. You can see here, outer rail is raised with respect to inner rail. Observe here also. Under that, next it is equilibrium cant or equilibrium super elevation. When lateral forces and wheel loads are almost equal, lateral loads as well as wheel loads, when both are almost equal, the cant is said to be an equilibrium cant. So at higher speeds, the centrifugal force will not be counterbalanced because super elevation increases will squares of the speed. So this causes overturning, and if it is at a lower speed, the tilt of vehicle inside may cause derailment for not completely counteracting centrifugal force. Both the effects you can see here. So when the speed is lower and speed is higher. And the relationship between super elevation and gauge width, speed, and radius of curve as follows. The super elevation will be the expression, it is GV squared divided by 1.27 times of R, where G is gauge width. So for broad gauge, it is 1.315 V squared divided by R, expressed in terms of centimeters. And for meter gauge, it is 0.80 V squared divided by R, and for narrow gauge, 0.60 V squared by R. You will have to remember these formulas for the calculation of super elevation for different gauge width. And the relationship between super elevation, gauge width, speed, and the radius of curve, and some of the notations we are going to use in this. So W, that is the weight of moving vehicle. Capital V is the speed of a vehicle in kilometer per hour. Capital R, radius of curve in meters. G, gauge width of track in meters. And small g, it is acceleration due to gravity. And alpha, it is the angle of inclination. S is the length of inclined surface in meters. So centrifugal force, it is given by WV squared divided by GR. This is the centrifugal force which will develop when the train travels on horizontal curve. And if we resolve the force along the inclined surface, we'll get this, the horizontal component outside, that is F cos alpha. So if you take the equilibrium condition, if you resolve the horizontal component of the centrifugal force as well as the weight component of the trine, so it will be W sine alpha and F cos alpha. Both are in opposite nature. So F equal to W V square by GR, and cos alpha it is G divided by S, and sin alpha is E by S. So you will have to remember this formula, E equal to GV square divided by 1.27 R. It is expressed in terms of centimeters. And then the equilibrium can. So when the lateral forces and wheel loads are almost equal, will provide a equilibrium can. We say that cant as equilibrium can. The cant is provided on the basis of average speed of trains. The majority of Indian railways provide superannuation for equilibrium speed or average speed under condition of level track. And the calculation of average speed or weighted average speed is N1 V1 plus N2 V2 plus N3 V3 divided by N1 plus N2 plus N3. That means how many number of trains are there and what is the respective speed of each train in terms of kilometers per hour. So product of velocity and number of trains divided by total number of trains. Solution you can see here the centrifugal force and weight component. Next it is a cant deficiency. The equilibrium cant it is provided on the basis of equilibrium speed of different trains. But this equilibrium cant or super elevation falls short of that required for high speed trains. So this shortage of cant is called as cant deficiency. So in other words, it is the difference between equilibrium cant necessary for maximum permissible speed on the curve and the actual cant which is provided. So this difference is called as cant deficiency. Higher cant deficiency causes more unbalanced centrifugal force and also discomfort to the passengers. So the maximum value of cant deficiency prescribed as per Indian Railways, if it is a broad gauge track 7.6 centimeter, meter gauge 5.1 centimeter, and narrow gauge 3.8 centimeter. So this maximum value of cant deficiency should not cross these values. Next, it is a super elevation. So when a branch line diverges from a main line on a curve of a contrary flexure, the super elevation necessary for average speed of trains running over the main line cannot be provided. So the super elevation, the speed of the trains over the diverging track and the mainline track has to be reduced considerably. So the reason for a reduction of speed is that on the branch line track, the inner rail remains higher level than the outer rail. So in such cases, we have to go for negative super elevation where the intersection of branch and main line happens. So obviously, we have to go for reducing the speed. So you can see the diagrammatic representation. There is a branch line and there is a main line. So here the control points A, B, K, and the inner line of branch line AF, inner line of main line BC, outer line of main line AD, and outer line of branch line B. These things you will have to look at. Here, the level of A with respect to main line, it is to be raised. But when it comes to branch line, so A cannot be increased. If we increase, so this level is going to be decreased. So then such elevation which we provide that we call it as negative super elevation. By referring this figure AD. So AD means this one. A to D. This line. AD, which is outer rail of mainline curve, must be higher than the inner rail BC. So here the inner line, this one is BC. So AD must be higher than this BC line. In other words, point A should be higher at higher elevation than elevation of point B. And for the branch line, however, BE should be higher than AF. So this B, it should be higher at higher elevation than AF. But that we can't provide. Or the point B should be higher than point A. These two contradictory conditions cannot meet at the same time within one layout. It is not possible. So outer rail BE of the branch line is kept lower than the inner line AF. So in such case, branch line curve has a negative superelevation, and therefore speeds on both tracks must be restricted, and especially branch line. So without reducing speed of mainline tracks trains, we are going to reduce the speed on branch line tracks. And calculations of restricted speed on the main line and branch line. When it comes to branch line, first we have to calculate the equilibrium superelevation for branch line. That notation you can give it as E suffix P. And superelevation can be found out by deducting the cant efficiency by this equilibrium cant. So EB minus CD, that will give you the superelevation. This is to be provided on main line, this value. And to calculate the maximum permissible speed for main line, cant value should be main line superelevation EM equal to X plus C. So that extra cant efficiency should be added over here. And the superelevation for main line, it can be calculated like this. First we have to calculate equilibrium superelevation for main line, this is EM. And the superelevation X will be equal to equilibrium superelevation minus cant efficiency for main line, how much it is, which is fixed for main line and efficiency. And provided cant and branch line, that is X, that is minus X, that is the negative superelevation which is provided. So to calculate a maximum permissible speed for branch line, in the cant should be EV equal to minus X plus CD. So that is CD minus X. So that's all about geometric design of railway tracks. And next, it is testing and specification of paving materials. That comes under pavement design and the materials, pavement construction materials. So some of the construction materials which we use for construction of roads, that is soil, aggregates, bituminous materials, and then cement concrete. So these are all the four materials we are going to use for construction of road nowadays. And first and foremost material, that is soil. So it is an integral part of the pavement structure which provides support to the pavement from beneath. The main function is to give adequate support to the pavement, and for this the subgrade should possess sufficient stability under adverse climatic condition and also loading condition. Poor subgrade, it will causes wave corrugations and rutting of roads and showing in black top movements and the phenomena of pumping of soil from beneath and blowing and consequent cracking of cement concrete pavement also may happen. So because of all these problems, the soil need to be stable and incompressible, and it should be of good quality. And some of the desirable properties of soil we expect, it should possess a better stability, incompressibility, and permanency of strength, minimum changes in volume, and stability under adverse climatic condition, and it should possess good drainage condition, and it should be easy to compact the soil properly. These are all some desirable properties of soil. Next, it is aggregates. So, aggregate, it can be defined as inert material fragments and the particles forming main structure of a mixture, such as tar macadam or concrete, and is the basic material for road construction. So, this material forms greater part of the body of road, and it will bears main stresses occurring in the road and resists wear from surface abrasion. The particles are bound together by bituminous materials, or it can be cement also, which act as binder and develop a strong structure forming the crust of road. The properties such as such materials should be known by a highway engineer for the formation of roads and bridges. So one of the important material used in road construction, that is aggregate. The material used for road aggregates, different types of aggregates we can use. Naturally occurring aggregates, that is crushed rock aggregates, gravels and sand we can use, and some of the artificial aggregates like a blast furnace slag, which is obtained as a byproduct in the manufacture of steel, that can be used. And some of the desirable properties of road aggregates are: it should be hard enough, it should be tough enough, it should be durable, and it should possess better interlocking effect, and then adhesion property with bitumen or any binder. These are all some desirable properties we expect from aggregates. When it comes to hardness, it is a measure of its resistance to crushing and the abrasion at the surface. That is the hardness. And toughness, it is the property that enables them to resist any friction when subjected to impact due to moving loads. It should be tough enough, and it should be durable, so that for a longer duration of time the road will be serviceable, and then it should possess better interlocking effect, that is cementitious value. Cementitious property comes from the ability of the road stone to form its own binding material under traffic, so as to make the rough broken stone pieces grip together, imparting resistance to displacement. And then it should possess better adhesive property with bitumen as well as sand. So some of the tests on road aggregates to assess its quality, and it is to decide suitability of road stones for use in construction. Some of the following tests are carried out: crushing test, abrasion test, impact test, soundness test, shape test, specific gravity and water absorption test, vitamin addition test. So these are all some experiments, laboratory experiments can be conducted to assess the quality of aggregates we use. So first one, that is attrition test. So it is to check uh, the resistance against the wearing action, that you can say abrasion value. So how this test conducted is, basically this test determine the percentage of wear of a given broken stone sample. So this is a combined test for determining the suitability of stone for hardness as well as toughness. Both we are going to assess. So when dual abrasion test is carried out by dual machine without using any abrasion charges, the test is known as dual attrition test. The apparatus like this, a dual attrition testing machine we should have, and a balance with ISU number 1.7 mm. This test is conducted for rock specimens as well as gravel specimens. and this equipment will be consisting of a pair of hollow iron cylinders of internal diameter 200 mm and a length of 340 mm. Cylinders are fixed to a frame over here, which in turn is connected to a shaft that is rotated by means of a motor at the rate of 30 revolutions per minute. And the cylinders are inclined to the horizontal axis at an angle of 30 degree also. If the gravel is to be tested, it shall consist of uncrushed fibers. Sample of material shall first be separated into different sizes, and those should be washed and then dried before mixing them to form a required grading. And the total weight of sample shall be 5 kg when it is dried. And the conduction procedure measure a 5 kg of sample in both the cylinders of a dual adhesion testing machine, put it inside it, and close the cylinders. Allow the cylinders to rotate 10,000 revolutions at the rate of 30 revolutions per minute. Totally 10,000 revolutions. After giving a 10,000 revolutions, take out the contents from the cylinders and then sieve these to 1.7 mm and take the weight of quantity of material which is retained on this 1.7 mm sieve that is named as W2, and finally you calculate the percentage of wear as loss in weight when we have given 10,000 revolutions divided by initial weight which we have taken, that is 5 kg. That means W2 W1 minus W2 divided by W1 into 100. Thus, that will give us the percentage of wear. If the wear is more than 3%, that such kind of stone is not satisfactory for construction. If it is equal to 3%, that is just tolerable. For a good stone, wear should be less than 2%. That is good. And to assess the same property, we have another test, that is the Los Angeles abrasion test. So this test is carried out on crushed rocks, crushed slag, crushed gravel, or crushed gravel. So here the inference, the Los Angeles abrasion value for good aggregates are acceptable for cement concrete and bituminous concrete and other high quality pavement materials, and it should be less than 30%. And for waterborne macadam and bituminous macadam roads, it can be up to 50% also, the acceptable limit. And the apparatus we use over here is a Los Angeles operation testing apparatus with a drum, and it will be consisting of steel charges. Weighing balance is required, and then sieves of size 1.7 mm, and the different sieve sizes based on the grade of aggregate which we are testing. These are all the operators which are required. And test sample, it consists of a clean aggregate which has been dried in an oven dry to a substantially constant weight conforming to one of the grading. So different grade like A, B, C, D up to H, different gradings will come based on the size of aggregate and the fraction. In the test procedure, so the test sample first it is placed in the Los Angeles machine along with abrasive charges are poured consisting of steel balls. The number of steel balls to be fed are 12 in case of grade A, E, F, and it can be 11 for the grade 11, and in case of grade B is 8 number of charges. In case of grade C, 6 number of charges we can use. Average weight of each ball will be around 417 grams. It can vary. Size of the ball being 4.76 centimeters. Machine is started after filling the materials and the steel charges. So after filling it, totally 500 revolutions we should give for the grading ABC, and it can be 1000 revolutions per grade E, F, G. So after giving these 500 or 1000 revolutions for different grades, material is taken out and sieved to 1.7 mm sieve. The material which is coarser than this size is washed, dried in an oven drying at a temperature of 105 degree to 1010, 110 degree Celsius at to a constant weight. The difference between this weight and the original weight which we have taken initially. So that value divided by original weight we have taken into 100, that will give us the abrasion value. And to assess the same property, we have another test, that is a Dory abrasion test, that also we can conduct. Here also a particular 1000 revolutions we will give. Initial specimen shape and size will be different. Yeah, and loss in weight after giving 10,000 revolutions divided by 3. 20 minus that value divided by 3, that will give us coefficient of hardness. The next, impact value test. So to check the aggregates are capable of taking a sudden impacts, we can conduct an impact value test. So it will be consisting of a cylindrical measure of different sizes. Stamping rod will have, and cylindrical steel cup of 10.2 centimeter dia and 5 centimeter depth, and it will be consisting of a hammer of a weight 13.5 kg to 14 kg, in that range. It will be consisting of one hammer and impact machine as per Indian code standard, and highest sieves of size 12.5 mm, 10 mm, and 2.36 mm. Totally 3 sieves are required. Initially, we have to take a sample, we have to do the sampling of aggregates. The aggregates which are passing through 12.5 mm sieve and retaining on 10 mm sieve. So these aggregates we have to do the sampling, and then pour these aggregates inside a cylindrical measure, that steel cup, 10.2 centimeter there and 5 centimeter depth. So place these filled aggregates inside the cylindrical cup below the hammer, and filling also should be in standard manner. In 3 layers, we have to pour the aggregates. Each layer we have to give 25 blows, that is stamping, and then level the surface of aggregates and place below the hammer. So after placing that, so lift the hammer and allow it to drop from a height of 38, that is 380 mm height, and continuously you give 15 number of blows. So 15 times the hammer is going to be lifted and allow it to freely fall on aggregates. So after giving 15 blows, aggregates are removed from a cylindrical cup and sieved through 2.36 mm sieve. Take the weight of aggregates which are passing through 2.36 mm sieve divided by total weight of aggregate which are taken initially for the test into 100 will give us impact value. Higher the impact value, lesser is the resistance of aggregates to the impact load. Lower the impact value, greater is the resistance against sudden impact. For bitumen macadam roads, if the impact value is greater than 35%, it is desirable. And in case of waterbound macadam, it should not be more than 45%. For bitumen macadam, can be in between 35 to 45. For a wearing surface, it should be less than 30%. Next, it is a crushing strength test. So this test is carried out to determine a crushing value of given aggregates. This test indicates suitability of aggregate for concrete and also give a measure of aggregate quality. And the operators use over here, it is a mold unit. It will be consisting of open-ended steel cylinder and with a plunger, a base plate will be provided, and a tamping rod of length 0.6 meters, weighing balance, highest use of size 12.5, 10, and 2.36 mm, and then compressive testing machine is also required. In case of rock specimens, the result is expressed as crushing strength, whereas in case of aggregates, the result is expressed as percentage of fines formed. So for the rock specimen, compressive testing machine shall be needed along with a spherical seating to ensure the loading is proper. So in this, first the aggregates are sampled by using a cylindrical measure. So fill the aggregates in 3 layers, give 25 blows, and then transfer these aggregates into the open-ended cylinder with a base plate. Fill it in a standard manner again 3 layers, 25 blows. So after that, level the aggregates and place the plunger on top of that. So keep this whole assembly in between the place of a compressive testing machine and start to apply the load at uniform rate. So totally 40 ton of load is applied, and then after applying 40 ton of load, stop loading and take out the whole assembly, remove the aggregates. So due to this huge load, aggregates will be crushed inside, and sieve these crushed aggregates through 2.36 mm sieve. Take the weight of aggregates which are passing through 2.36 mm divided by total weight of aggregates which were taken initially into 100. That will give us the crushing value. So higher the crushing value, lower is the resistance offered by the aggregates against crushing loads. So lower the crushing value, greater the resistance offered by the aggregates against such crushing. So aggregates which are used for base coats, the crushing value should not exceed 45%, and for wearing surfaces, it should not exceed 30%. So these are all the specifications. Next, it is a soundness test. So this test is done to study resistance of aggregates to the weathering action by conducting accelerated weathering test cycles. So in order to quicken the effects of weathering due to alternate wet, dry, or freeze thaw cycles in the laboratory, we can go for it. The resistance to disintegration of aggregates is to determine by using saturated solutions of sodium sulfate or magnesium sulfate can be used. So the procedure: take clean and dry aggregates, weighted and counted total number of aggregates and weight of aggregates you take it. So say it as a WM grams. So immerse these aggregates in the solution, that is sodium sulfate or magnesium sulfate solution for 16 to 18 hours, and then take it out, bone dry it at a temperature of 105 to 110 degree Celsius, and again immerse these aggregates in solution for 16 to 18 hours. Totally 10 number of cycles we have to keep on doing this. So after that, each aggregate is examined visually to see any evidence of excessive splitting is there or not, and crumbling is there or not. So if any disintegration is found, it should be noted down, and a sieve analysis is done to note the variation in gradation from original gradation to after disintegration gradation. Take the weight, that is W2, and finally calculate the loss in weight as W2 minus W1, which is initially taken. So after 10 cycles, if the loss is greater than 12% of sodium sulfate or 18% of magnesium sulfate, it is not acceptable. Next, it is a shape test. So different shapes of aggregates are available. It depends on the characteristics of parental rock or type crusher we have used, or reduction ratio, what size to what size the aggregate being reduced. All these factors will influence on shape of aggregate. So it is not acceptable like more percentage of flaky or elongated aggregates are there in sample of aggregate. So those kind of aggregates will reduce the strength of bituminous or cement concrete material which we are going to use finally. So the flakiness index and elongation index, the experimental procedure will be having thickness gauge for flakiness index, length gauge for elongation index. Here we'll do the sieve analysis, sieving first, and after doing the sieving, we'll take the weight of each fraction which is passing through a particular sieve site and retaining on and another sieve site. So after taking the weight of in each action, we'll try to pass through respective slots in thickness and length gauge. In case of thickness gauge, the weight of aggregates which are passing through the thickness gauge is taken, total weight, cumulative weight, divided by total weight of aggregates which were taken. So that will gives us the flakiness index, that percentage you multiplied by 100. And elongation index, the weight of cumulative weight of aggregates which are not passing through the respective slot in length gauge. That is the maximum size basically we measure in case of length gauge. So total weight of aggregate we have taken that divided by the weight of aggregate which are not passing through the length gauge through the respective slot into 100 gives us elongation index. In case of road, the flakiness index greater than 25%, it is not acceptable. So it is advisable to be less than 25%. And then another shape test, that is angularity index or angularity number. The degree of packing of particles of single sized aggregates depends on shape and angularity of the aggregates. So angularity is defined as 67% solid volume. The range of angularity number used in construction, it will vary from 0 to 11. Next, it is a water absorption test, specific gravity, and density test. So these tests are made on rock specimen. So for water absorption test, rock specimen is dried for 72 hours and then immersed in water for same period, and difference in weight gives the water absorbed. Aggregates is dried at 105 degrees Celsius to 110 degrees Celsius for 24 hours and is then immersed in water for 24 hours. The difference in weight gives this water is absorbed. And then specific gravity is calculated from the weight of aggregate of the rock specimen and the loss of water in water when it is immersed. Okay, so that's all about aggregates. And the next material we use, that is bituminous materials. Bituminous binders which are used in pavement construction works. It will include both bitumen and tar. Bitumen is a petroleum product which is obtained by distillation of a petroleum crude, whereas a road tar is obtained by destructive distillation of coal or wood. Both bitumen and tar have similar appearance, that is black in color, though they have different characteristics. Both these materials can be used for pavement works. and in that bitumen, majority of roads are constructed based in bitumen only, and it is a hydrocarbon material of either natural or pyrogenous origin, and it is found in a gaseous state or liquid, semi-solid or solid form, and it is completely soluble in carbon disulfide and in carbon tetrachloride. Bitumen is a complex organic material and occurs either naturally or may be obtained artificially during the distillation of petroleum products. Bituminous materials are very commonly used in highway construction because of their better binding ability and also their waterproofing properties. And some of the laboratory experiments to check the quality of a bitumen. First one, it is a penetration test. So this test is conducted to check the hardness of bitumen and for grading the bitumen. So this test determines the hardness or softness of bitumen by measuring the depth in length of a millimeter to which a standard loaded needle will penetrate vertically in 5 seconds. It will be consisting of one vertical needle. It is allowed to penetrate into the standard specimen inside it. So here what we'll do, first we'll take the bitumen and we'll heat it to a pouring temperature. We'll be having a cup, we'll pour it inside and we'll allow it to dry for a duration of air dry for a duration of 30 minutes, and it should be kept in water for a duration of 60 minutes before testing, and then keep this specimen below the needle and bring the needle until it touches top surface of bitumen and allow this needle to penetrate inside the bitumen for a duration of 5 seconds. So note down the depth of penetration. So that is expressed as penetration value. So bitumen grade, it is specified in terms of penetration value. That is 80 by 100 grade bitumen means penetration value of bitumen is in the range of 80 to 100. So like that, different grades are available. The range of penetration value used in pavement construction, it is in around 20 to 225. So generally 30 by 40 and 80 by 100 grade bitumen are used depending upon the type of construction and also the climatic condition. Next test, it is ductility. So another desirable property we expect from bitumen, it is ductility. So this is the one property which can extend without any breaking or forming any crack. So without a ductility, if bitumen is not possessing ductility value or ductility means, then there would be so many cracks on the road. So as the bitumen is ductile in nature, it will bind, uh, it will hold the aggregates properly even though it is extending and do not allow the crack to form. So ductility of a material is its property to elongate when subjected to tension before break. Ductility of bitumen is expressed as the distance in centimeters to which a standard briquette of bitumen can be stretched before the thread breaks. And some of the apparatus we use in this experiment, that is a brass mold, that is briquette apparatus, and its dimension total length will be in range of 7.45 to 7.55 centimeter, and its maximum width will be 2.97 to 3.03 centimeters, and width at the mouth of the clip 1.98 to 2.02 centimeters, and width at the minimum cross section it is around 0.99 to 1.01 centimeters, and its thickness will be in the range of 0.99 to 1.01 centimeters. So this is the briquette apparatus, and the testing procedure is first in the briquette bring the bitumen to pouring temperature of around 75 to 100 degrees Celsius, and then pour this bitumen inside this briquette mold. So this hatched portion will show you the bitumen portion which is to be poured. So before pouring, make sure that glycerin and dextrin mixture is applied inside it so that the bitumen is not going to be adhered to the surface. So after pouring, wait for a duration of air cooling 30 minutes and keep it inside water again for a duration of 30 to 60 minutes. So place this briquette mold, fix it in electricity testing apparatus, and a standard temperature of 25 degrees Celsius is maintained in a water bath for a duration of 85 to 95 minutes. And then the flexibility testing apparatus will be consisting of one fixed end and another moving end, which on the machine. So moving end will start to move and bitumen will start to get stretched. So at certain length when it is achieved, so the thread will break. Note down the length by which the thread is broken. That length is nothing but the ductility value. So minimum ductility value of 75 centimeter has been specified by ISI for bitumens of grade 45 and above, obtained from the sources other than Assam Petroleum. The minimum ductility value may be 50 centimeter for bitumens of grade S35 obtained from these sources. Next experiment, it is a softening point test. Bitumen is a non-crystalline material or viscous material having adhesive properties derived from petroleum either by natural or refinery process. So in residual transition of asphaltic bitumen from a solid to liquid state, it is not possible to determine exactly the temperature at which it becomes fluid. The temperature at which the bitumen softens and becomes more of less fluid is of considerable importance, and arbitrary tests have therefore to be employed. This temperature is called as softening point test. Higher the softening point indicates lower temperature susceptibility and is preferred in warm climatic conditions. And the apparatus required for conduction of this test, ring and ball apparatus is required, brass frame is required, beaker is required, level glass plate is required, steel ball of 10 diameter, a spirit lamp is required. So first we'll place a level glass plate in a horizontal platform and we will apply the mixture of dextrin and glycerin to it, and keep the standard ring 16 diameter and 6 in thick on glass plate, and bring the bitumen to pouring temperature in between 75 to 100 degrees Celsius and pour it inside the ring. Allow it to cool for a duration of 30 minutes and cut away the excess amount of bitumen which is added on top. Place the standard ball that is 10 diameter at the center of bitumen. So there will be a guider in the apparatus, and after placing, suspended the whole unit in a beaker. This with the brass frame, we have to suspend it in the whole beaker of water capped at a temperature of 5 degrees Celsius with a thermometer ball. So cold water we are going to use in this test. Then we'll start to increase the temperature, and initial temperature will be 5 degrees, and at a rate of temperature increase 5 degrees Celsius per minute, we are going to increase the temperature. Bitumen in the ring, it will start to melt, and this steel ball passes through the test measurement, forming a bulb. So when the bulb reaches the 25 in depth, there will be another mark in that frame. So at a level of 25 mm below it. So when it reaches that level, note down the temperature. So this temperature is nothing but the softening point of that bitumen. So softening point temperature for residual and air-blown bitumen of grade 90 is in between 42 to 91 minutes, and grade 200 it is between 35 to 40 degrees Celsius. For flux native asphalt grade 90, it is in between 40 to 47 degrees Celsius, and grade 200 it is in between 35 to 45 degrees Celsius. So this is what certain information is about softening point test. And next it is flash and fire point test. So flash point of a material means it is the lowest temperature at which vapor of a substance momentarily taken fire in the form of a flash under specified condition. And then fire point is the lowest temperature at which the materials will get ignited and burns under specified conditions of test. And apparatus we use for this, it is Penske Martin's closed cup apparatus or open cup apparatus. And the minimum specified, the specifications, minimum specified flash point of bitumen used in case of pavement construction in Penske Martin closed cup time, it is 170 degree Celsius. Next test, it is a viscosity test. So viscosity, it is a measure of resistance to the flow. So there is an optimum value of viscosity for each aggregate gradation of a mix and the bitumen grade. At low viscosity, bituminous binders simply lubricates the aggregate particle instead of providing a uniform fill for binding action. So the bitumen will not get adhered properly throughout the surface of aggregate with a lower viscosity. So similarly, higher viscosity also resists the compactive effort and resulting the mix in heterogeneous in character and exhibit the lowest stability value. So orifice type of viscometer we can use, and indirectly we can find the viscosity of liquid binders like a cutback bitumen emulsion and a liquid tar we are going to use. According to this method, viscosity is measured by determining the time taken for 50 ml of material to flow from a cup through a specified orifice under standard test condition and the specified temperature. Higher the viscosity of binder, higher will be the time taken to flow through the specified orifice. Next, it is a specific gravity test. Specific gravity of a bituminous material, it is defined as the ratio of mass of a given volume of substance to the same of an equal volume of water. The temperature of both being 27 degrees Celsius. The specific gravity is determined either by using phycometer or by preparing the cube-shaped specimen in semi-solid or solid state and by weighing it in air and water. So generally, the specific gravity of a pure bitumen, it will be in the range of 0.97 to 1.02. The specific gravity of a cutback bitumen may be lower. It is depending upon the type of preparation of diluent which is used, and the tars have the specific gravity ranging in between 1.10 to 1.25. And then next material we use in case of pavement construction, that is cement, especially in rigid pavement construction. So it is used as a binder in construction of cement concrete and cement ground type roads. And to check the quality of cement, some of the field tests there was some internet connectivity problem. It is fine now. So the next material we use for construction of road, it is a cement. So it is used as a binder. And some of the field tests that we conduct uh, to assess the quality of cement. It is color. It should be greenish gray color. And then some of the physical property. If you thrust your hand into the bag of cement or into the cement, it should be cool, and you should feel smooth enough. If you feel in between the fingers, if you take pinch of cement and you feel it in the fingers, and then there should be no lumps present in it, and it should be stable enough. If you make a pat of cement and immerse inside the water and wait for a duration of 30 minutes and check. And some of the laboratory experiments to check the quality of cement, that is to find some physical and chemical properties of cement we can find, and to regulate various stages in manufacturing process, and to understand behavior of cement after its use in the works. To check these things, we can first connect it. Yeah, some of the chemical composition test for the presence of lime and alumina. Uh, the specifications, it should not be less than 0.66% and not more than 1.02%, and it can be calculated by using this expression. And magnesia, it should not be greater than 5%, and the loss on ignition should not be greater than 4%. And total sulfur content should not be greater than 2.75%, and insoluble residue should not be greater than 1%. These are all some chemical composition specifications. And when it comes to physical properties, some of the laboratory experiments we do. First one, it is a fineness test. It can be conducted by using a sieve or Blaine's air probability test apparatus. In case of sieve, 100 mm 90 micron sieve we use. Around 100 grams of cement we take and we sieve it to 90 micron sieve to for a duration of 15 minutes continuously. And we will weigh the residue which is left over 90 micron sieve, and this residue should not be greater than 10 grams with respect to 100 grams. If you express it, that is 10% by weight of cement. And another test is there, that is Blaine's air probability test. So through a prepared cement bed, a definite quantity of air we are going to suck. So how much duration it is taking to draw a definite quantity of air through the prepared cement bed of porosity 0.5. So that we are going to check. Higher the duration it is taking means great, so greater the fineness, lesser the duration it is taking means lesser the fineness. We have equation for that, k into root t, where k is the apparatus constant and t is the time which is taken to draw definite quantity of air through the prepared cement bed of porosity 0.5. And the next one, compressive strength of cement. So in this, we use cement and fine aggregates mixture with a proportion 1:3, and we'll mix it until we get uniform color, and then calculate the quantity of water, that is P by 4 plus 3.5% by combined weight of cement and aggregates. So where Pn is the uh, standard consistency or normal consistency percentage. So that much quantity of water, you pour it, mix it properly, and prepare a cubical specimens of size 7.06 by 7.06 by 7.06 centimeters. After 24 hours, you demold it and keep it in water for curing purpose. After 28 days, you can take it out 3 number of cubes and test it for compressive test. So this is the procedure. So 3 days, 7 days, 14 days, 21 days, 28 days. So what is the whatever the duration you are looking for, you can test it. And temperature in between 25 degree to 29-degree temperature, it should be kept for curing. And then next test, it is consistency, that is normal consistency test. For this, we should have a Y-cut apparatus. So it will be consisting of different needles for standard consistency, initial setting time, and final setting time. So for determination of consistency, around 300 grams of cement will take, and a certain percentage, like you can start with 10% also, but however, as it is very stiff in nature, you can start with around 24 to 25 percentage of water you mix it well. And after a proper gauging, fill it the prepared cement paste inside the Y-cut mold, and we will be having a plunger. So bring this plunger until it touches top surface of prepared cement paste. Allow it to penetrate inside. So check the depth of penetration. It is not in the range of 5 to 7 mm. So that means if it is less than 5 mm, means you can go for increasing the water content from 25% to 26 or 27%. So keep doing until you get depth of penetration in between 5 to 7 mm. So once you get it, so that is the particular percentage of water where the standard consistent cement paste we are going to have. So that is the test. And then for checking the initial spin time and final spin time, we'll be having different needles. So in case of initial setting time, that means we know that initial setting time, it is the time between adapts between the moment at which water is added to the cement paste and the time at which cement start to harden. So this experiment, same 300 grams of cement will take, at 0.85 times of normal consistency value of water we are going to calculate, gauge it properly and fill it in wicket mold and place it below the wicket apparatus. Bring the initial setting time needle until the top surface of cement paste. Allow it to penetrate. So depth of penetration you see whether it is in between 5 to 7 mm or not. So if it is not, like less than 5 mm means, so wait for some more time. So repeat the same until you get the depth of penetration in between 5 to 7 mm. So you will have to record the time in between the moment at which water is added to the cement and moment at which the depth of penetration you are going to get in between 5 to 7. So this particular time which is elapsed in between this is called as initial setting. The next final setting time. So this is the time elapsed between the moment at which water is added to the cement to the moment at which cement completely hardens. So here the same cement paste which is used in case of initial setting time, it is continued with a different needle. So that needle is brought to until it touches top surface, and we should wait until it the needle fails to make its impression. But uh, uh, so the final setting time needle, it will be consisting of one extra projected this one. So that mark should not come. Next, it is a soundness test. So this test is carried out to find out changes in volume that may take place after setting. So the Lee-Chatelier apparatus we use over here. It will be Lee-Chatelier apparatus. It will be consisting of one brass mold with a diameter of 30 mm and height of 30 mm. So there is a split in the mold. The split does not exceed 0.5 mm. On other side of the split, there are two indicators with pointed ends. Thickness of the mold, it will be in the range of 0.5 mm. And the conduction procedure, the cement paste, it is prepared and it is filled in the mold, is placed on the glass plate. Then it is covered at top by another glass plate. The whole arrangement is placed inside the water for a duration of 24 hours at 24 degrees Celsius temperature. The distance between the indicators is noted down before. Mold is again placed in water. Heat is applied in such a way that boiling point of water is reached in about 30 minutes, and the boiling is continued for 1 hour, and then mold is removed from the water and it is allowed to cool down. The distance between the indicators is again measured after taking it out. The difference between two readings indicates the expansion of cement. The difference between the two readings should not be greater than 10. That is the specification. So that's all about the materials used for cement construction. So we are in connection. Next, it is a design of highway payments. So objects and the requirements of payment, it is types of payments are rigid payment, semi-rigid payment, and flexible payment. Rigid payment, these possess a better flexural strength and a better flexural rigidity. Its design is based on providing a structural cement concrete slab of sufficient strength to resist a destructive action of the traffic. Because of its rigidity and high modulus of elasticity, it tends to distribute load over a relatively wide area of soil, and minor variations in the subgrade strength, those are all having a little influence on the structural capacity of rigid pavement. In the design of flexural strength concrete, in the design, the flexural strength of concrete is the major factor and not the subgrade strength. It is because of the fact that when the subgrade deflects beneath the rigid pavement, concrete slab is able to bridge over a localized failure and area of inadequate support because of the slab action. And the next type, it is a flexible pavement. Flexible pavement. These on the whole have low or negligible flexural strength when we compare with rigid pavement, and they are rather flexible in their structural action under the loads. They may be defined as one consisting of a mixture of asphaltic or bituminous material and aggregates which are placed on a bed of compacted granular materials of appropriate quality in layers over the subgrade. So its design, it is based on the principle that a load of any magnitude, by carrying it deep enough into the ground through successive layers of granular materials, the intensity of a load diminishes as the load is transmitted towards down from surface by the virtue of spreading over an increasing larger area. Consequently, there could be grading in the quality of materials which are used. The materials with a high degree of strength being used near the surface. Thus, strength of subgrade primarily influence the thickness of design of flexible pavement. So here, when we compare with rigid pavement, so the strength of subgrade is important. And then semi-rigid pavements. So when bonded materials like pozzolanic concrete, like in place of cement, fly ash, lime fly ash aggregate mix it is used. Lean cement concrete or soil cement are used in the base course or sub-base course layer. The pavement layer has considerably higher flexural strength than common flexible pavement layers. However, these bonded materials do not possess as much as flexural strength which is possessed by cement concrete pavement. Therefore, when this intermediate class of materials are used in the base or subbase cores or layers of the pavement, they are called as semi-rigid pavement. So these materials have low resistance to the impact, the abrasion. Therefore, they are usually provided with flexible pavement for surface cores. And some of the difference between flexible and rigid pavements. So flexible pavement, it consists of a series of layers with highest quality of materials at the surface, whereas a rigid pavement, it will be consisting of one layer of Portland cement concrete slab of relatively high flexural strength. So flexible pavement, it reflects the deformation of subgrade and subsequent layers on the surface, whereas a rigid pavement not able to is it is able to bridge over localized failures and areas of inadequate support. So flexible pavement, its stability is depending upon the aggregates interlocking, particle fraction, and the particle friction and the cohesion. Whereas a rigid pavement, its structural strength is provided by pavement slab itself by its beam action. Pavement design is greatly influenced by subgrade strength in case of flexible pavement. Structural strength of concrete is a major factor of design in case of rigid pavement. In case of flexible pavement, it functions by a way of load distribution through the component layer, whereas rigid pavement, it distributes the load over a wide area of a subgrade because of its flexural rigidity and high modulus of elasticity. Temperature variations due to change in atmospheric conditions do not produce stresses in flexible pavement, whereas temperature changes induces heavy stresses in rigid pavement. In case of flexible pavement, it has self-healing properties. Deformations occurring due to heavier wheel loads are recoverable to some extent, where in case of rigid pavement, any excessive deformation occurring due to heavier wheel loads are not recoverable. That is, settlement is permanent in case of rigid pavement. And you come for design of rigid pavements. Cement, concrete pavements represent a group of rigid pavements. Here, the load carrying capacity is mainly due to flexural rigidity and high modulus of elasticity of the slab itself, that is the beam action of slab. Westergaard's considered that rigid pavement slab as a thin elastic plate which is resting on soil subgrade, which is assumed as a dense liquid which is resting on subgrade. Here it is assumed that upward reaction is proportional to the deflection, it is P equal to K delta, where K is a constant which is defined as a modulus of subgrade reaction, and unit of K is kg per centimeter square per centimeter of deflection, that is kg per centimeter cube. And Westergaard's modulus of subgrade reaction, that equation K equal to P by delta, just now of a subgrade reaction K is proportional to the displacement. Displacement level here it is taken as 0.125 centimeter in calculating the value of K. If P is the pressure sustained in the kg per centimeter square by the rigid plate of diameter 75 centimeter at a deflection of 0.125 centimeter, then this equation can be written as K equal to P divided by 0.125 kg per centimeter square. So you'll have to remember this equation, K equal to P divided by 0.125 kg per centimeter square. The relative stiffness of the slab to the subgrade. The Westergaard defined radius of relative stiffness as EH cube divided by 12 times of K into 1 minus mu square, where L is the radius of relative stiffness expressed in centimeters, and E is the modulus of elasticity of.
ಸರ್
Yes,
ಸ್ಕ್ರೀನು ಕಾಣಿಸ್ತಾ ಇಲ್ಲ ಸರ್. ಶೇರ್ ಮಾಡಿಲ್ಲ.
share ಮಾಡಿದ್ಯಾನಾ?
ಇಲ್ಲ ಸರ್.
ಅದು ಇನ್ ಬಿಟ್ವೀನ್ ಇದಾಗಿತ್ತು, ಇಂಟರ್ನೆಟ್ ಕನೆಕ್ಷನ್ ಹೋಗ್ಬಿಟ್ಟಿತ್ತು.
ಹಾಂ ಸರ್.
Just a minute. ಮೊದಲೇ ಹೇಳೋದಲ್ವೇನೋ, ನೋಡೇ ಇಲ್ಲ ಅನ್ಸುತ್ತಲ್ವಾ ನೀವು?
ಇಲ್ಲ ಸರ್, ಮೆಸೇಜ್ ಹಾಕ್ತೆ ನಾರ್ಮಲ್ಲು.
ನಂದು ಮೊಬೈಲ್ ಸ್ವಿಚ್ ಆಫ್ ಆಗ್ಬಿಟ್ಟೆ
ಅದೇ
ಇಂಟರ್ನೆಟ್.
ಸರ್ ಸ್ವಿಚ್ ಆಫ್ ಅಂತ ಬಂತು. ಅದೇ
ಈಗ ಮತ್ತೆ ರಿಪೀಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ ನನಗೆ.
ಹಾಂ ಸರ್.
1 hour ಅಟ್ಲೀಸ್ಟ್ 1 hour ಇತ್ತಲ್ವಾ ಅದು?
ಅದನ್ನ ಡಿಸ್ಟರ್ಬ್ ಮಾಡಬಾರ್ದನಲ್ವಾ, ಅದಕ್ಕೆ ಸುಮ್ಮನೆ ಇದ್ದೆ ಮೆಸೇಜ್ ಹಾಕಿ.
ಏನು
ಮೆಸೇಜ್ ಹಾಕಿದ್ದೆ ಸರ್ ನಿಮಗೆ ಫೋನಲ್ಲಿ, ಮತ್ತೆ ಕಾಲ್ ಎಲ್ಲ ಮಾಡಿದೆ.
ಸ್ಕ್ರೀನ್ ಈಸ್ ನಾಟ್ ವಿಸಿಬಲ್.
ಅದೇ ನೀವು ಡಿಸ್ಟರ್ಬ್ ಮಾಡಬಾರ್ದನಲ್ವಾ,
ಓ ಹೇಳೋದಲ್ವೇನೋ?
ಅದಕ್ಕೆ ಸುಮ್ಮನೆ ಇದ್ದೆ ಸರ್.
ಈಗ ನೋಡಿ ಇಲ್ಲಿ ಸ್ಕ್ರೀನ್ ಕಾಣ್ತಾ ಇಲ್ಲ ಅಂತ 9 ಗಂಟೆಗೆ ಯಾರು ಹೇಳಿದಾನೆ? ನೀನೇ
ನಾನು
ಹೇಳಿದ್ದೆ.
ಹಾಂ ಸರ್.
ಹೇಳೋದಲ್ವೇನೋ?
ಅದೇ ಡಿಸ್ಟರ್ಬ್ ಮಾಡಬೇಡ ಅಂದ್ರಲ್ವಾ, ಅದಕ್ಕೆ ರೆಕಾರ್ಡ್ ಆಗುತ್ತೆ ಅಂತ ಸುಮ್ಮನೆ ಆಗೋದೆ.
ಎಷ್ಟು ಗಂಟೆಯಿಂದ ಕಾಣ್ತಾ ಇಲ್ಲ? 9 ಗಂಟೆಯಿಂದನಾ?
ಹಾಂ ಸರ್, ನಿಮ್ಮದು ಕನೆಕ್ಷನ್ ಲಾಸ್ ಐತಲ್ವಾ,
ಹಾ,
ಅವಾಗಿಂದ ಕಾಣ್ತಾ ಇಲ್ಲ.
ಸುಮಾರು 1 ಕಾಲ್ ಗಂಟೆ ರೆಕಾರ್ಡ್ ಆಗಿದೆ ಈಗ.
ಹಾಂ ಸರ್.
ಇಂಟರ್ನಲ್ಸ್ ಯಾವಾಗ ನಿಮ್ದು?
ಮಂಡೇ.
ಮಂಡೇನಾ?
ಹಾಂ ಸರ್.
ಓಕೆ, ನಾಳೆ ಒಂದು 45 ಮಿನಿಟ್ಸ್ ಯಾವಾಗಾದ್ರು ಹೇಳ್ತೀನಿ.